So I just wanted to go over number 1 and number 3 from the back side of that handout that we looked at in the last minutes of class on Friday. And so I've got this function, this piecewise function with 3 parts to it. And so I'm going to make a table of values. I think that's the easiest way to think about this. So I've got the x, and since I've got 3 rules, I'm going to actually make a table of values for each part of the 3 rules. So negative x plus 1. And I'm going to look at these for different input values of x. So if x is less than 0, I'm going to plug in some numbers that are less than 0. So my favorite number that's less than 0 is negative 2. So if I plug that into this rule, because that's the rule for when x is less than 0, I get negative 2 plus 0. I'm sorry, negative 2 plus 2, which is 0. And then I want to go up to but not include 0. So I'll put 0 here just to find out where that end boundary is. And so 0 plus 2 is 2. So I'm dealing with everything from 0 to, so 0 to open circle at 0, 2. And at negative 2, 0, that's an x value that's less than it. So I'm dealing with all of the points less than 0, 2 along that line, x plus 2. Okay. Let's look at the next part then. 2x plus 5 between 0 and 2. So here I'm going to start at 0, right? This is my input value here. So I'm going to start at 0 and I'm going to put it into this rule. So 0 plus 5, well, that's the point 0, output value 5. And this one is inclusive, so closed dots. 0, 2, 4, 5. And I'm going to go up to 2. And at 2, I've got 4, that's 9. 2 times 2 is 4 plus 5 is 9. So at 2, I'm at 2, 4, 6, 8, 9. So I'm going to connect those dots. The last piece here I'm going to look at is this rule if I've got greater than 2. So I'll start at 2 because that's my boundary. So I've got negative 2 plus 1 is negative 1. So at 2, negative 1, I've got an open circle. That's right about here. I'm actually going to erase this 2 so we can see it. So at 2, negative 1, got an open circle. And I need a number bigger than 2. Well, let's try 4 maybe. So if I put a negative 4 plus 1, that gives me negative 3. So at 4, negative 3, 2, 4, I'm down here at negative 3. So I'm going to connect those dots, and that is my graph. So these are the 3 parts of the graph. I have the part for when x is less than 0 here. I've got the part for including between 0 and 2, right, inclusive. And I've got this part for x is greater than 2. So those are the graph. So let's consider the domain and range for this. So the domain are the x values. So we're looking at all of the values of x such that, well, this arrow goes forever that way, and this arrow goes forever this way, and all of these values are included here because when it's not this, it's this, right? Okay, so we're really talking about negative infinity here to, positive infinity, okay? All real values. The range looks like it's includes everything less than 2, or we could be up here between 5 and 9, right? So we've got sort of two range values. So we've got a union for our range values. So we've got y such that y is less than 2, or union, we've got 5, so y is greater than or equal to 5, and less than or equal to 9 for this piece in here. So those are our range values. Let's look at number 3 as well. I'm just going to do the same thing. So I'm going to break it up into 3 parts. I'm going to look at this part, and then I'm going to look at this part, and then I'm going to look at this third part. So I'm going to make a table that represents that. So I've got the input value, the x, I've got x over 3 for some of it, I've got 2x minus 6 for some of it, and I've got 1 for some of it. So again, x minus 3 is the rule for when x is less than or equal to 0. 2x plus 6 between 0 and 2. And 1 for greater than or equal to 2. So let's just plug in some values. So I'm going to use -3 as my value that's less than 0 here, because that'll give me a nice answer. And then I'm going to do 0, and so that gives me 0 divided by 3 is 0. So here I've got my points. This is a closed endpoint because it's or equals to. So closed dot at 0, 0, -3, -1. So we're talking those values there. And then I'm going to look here. So I'm between 0 and 2. So for 0, if I input that, I get -6. If I input 2 into this rule, I'm going to get 4 minus 6 is -2. So, and those are open circles. So 2, -2, open circle. This time I'm counting by ones. Hope that'll work. And 0, -6. 1, 2, 3, 4, 5, 6. There we go. And so connect those. And then the last part here is this magenta part, which is when x is greater than 2. So, well, the output's always 1. So if it's 2, then it's 1. That's greater than or equals 2. And if it's, I don't know, 4, the output is also 1. So at 2, the output is 1, and that's an or equals 2. So it's solid dot. At 4, it's 1. So that is this horizontal line going here. So the domain again for this is all values of x from -infinity to +infinity. And the range is going to be in 2 parts. We've got all the values of y that are less than or equal to 0. So we've got y is less than or equal to 0. Or y could be equal to 1. So we could have this, or we could have anything underneath here. This is included in any values less than 0 already, so I don't need to have a separate mention of that. Okay, great. Well, I hope that helps you sort of look over your results from class on Friday. Thanks so much.